about sigma notation, sometimes called summation notation. Suppose that we have a sequence that looks like this: a sub 1, a sub 2, a sub 3, a sub 4, and so on. And suppose we wanted to find the sum of some of the terms of the sequence. We could write it this way. We're going to use the capital Greek letter sigma. That's why it's called sigma notation. But we're going to be finding a sum, which is why it's called summation notation. So we say we're going to take the sum of a sub k, starting with k equals 1. Whoop, that doesn't look like an equals. That's a k equals 1 to n. If we have a summation that looks like that, it means you substitute k equals 1 in, so we would have a sub 1, and then you increment this index by 1 and add. So we would move up to a sub 2 and continue substituting in 3, so we'd have a sub 3. And you continue until you get to n. So this summation notation allows us to write this sum in a very compact form. The k that we used here is called the index. Sometimes we use k, sometimes you'll see I or j used for the index. So now we're going to practice using summation notation. So let me start with this one. We'll use the sum of 3k, starting with k equals 1 to k equals 5. So we start with k equals 1 and substitute it into the expression. So we have 3 times 1 plus, right? The summation means you're going to add. We substitute k equals 2 into the expression. And then k equals 3 and k equals 4. And we stop when we get to this number, k equals 5. And we can calculate the sum just by doing that arithmetic. So we have 3 plus 6 plus 9 plus 12 plus 15. And if we add these together, we have 9 plus another 9 is 18, plus 12 is 30, plus 15 is 45. So the sum of 3k from k equals 1 to 5 is 45. Let's do another summation. Let's find the sum of 5 over I squared with I starting at 1 and finishing at 3. So for I equals 1 to 3. So we substitute in 1, so we would have 5 over 1 squared plus, substitute in 2, we just increment by 1, and we stop when we get to 3. So we're simply finding that sum. So we have 5 plus 5/4 plus 5/9, and now we realize we just have an arithmetic problem, right? Common denominator of 36. So we could write that as 180 over 36. Let's see, this one will multiply by 9 over 9, so that's 45 over 36. And this one will multiply by 4 over 4, so we have 20 over 36. So we would have 245 over 36. Let's see, factors of 2 and 3 go into 36, but neither 2 nor 3 goes into 245, so I can't reduce it. So the sum of 5 over I squared with from I equals 1 to 3 is this sum right here. Let's do another one. Let's find the sum of -2 to the j power. And we'll start with j equals 5. There's nothing that says it has to start at 1. And we'll go to j equals 8. Sometimes people misunderstand what this number here means. It does not mean we have 8 terms. It means we start at j equals 5 and we stop when we get to j equals 8. So this sum would be -2 to the 5th power, starting with j equals 5. So we pop in 6, and then 7, and then 8. So here's our sum. And we do our calculations. -2 to the 5th power is a negative number. 2 to the 5th is 32, so we have -32. Now we'll have a positive number, and we have positive 64. We're back to a negative number, -128. And last we have a positive number, positive 256. So we can add these terms together. Let's see, these two add up to 32, these two add up to 128. I just grouped them that way just because it seemed convenient to me. So 32 and 128 is 160. Of course, you can add them from left to right or add the negative ones together and then the positive ones together, however you like. But we should come up with 160. Let's do one that's a little bit different. How about this one? Let me separate it. Let's look at the sum of 8, starting with k equals 1 and going to 400. Now remember, this is our formula for the terms of the sequence. And you look at that, you go, but I don't even have a k there. That's right. So if k equals 1, this expression is 8. Plus, when k equals 2, this expression is 8. When k equals 3, this expression is 8. K equals 4, k equals 5, and keep going until we get to k equals 400. So this is a nice way to express the sum of a 400 eighths. But we aren't going to just add 8 plus 8 plus 8 plus 8. We know there are 400 eighths. So we know that that's really 400 times 8, or 3,200. Now, this summation notation is nice for other expressions that look like that. So for example, you could have I equals 1 to 350 of 4i plus 1. And certainly we would not write out 350 terms. We could write out a few, and we would substitute I equals 1 in, so 4 times 1 plus 1, and 4 times 2 plus 1, and you could continue until you get to I equals 350. So when we know the last term would be 4 times 350 plus 1. Now to find the sum, we would need to be talking about some strategies that we haven't gotten to yet, just based on this sum formula. So you're going to need to make sure that you watch more videos to find out how to actually calculate this. I'll give you a hint. You can use some of an arithmetic sequence, but that's a talk for another day.